Hello and welcome back to Saxon Math. This is Lesson 65, Prime Factorizations, Division by Primes, and Factor Trees. Every whole number greater than 1 is either a prime number or a composite number. A prime number only has two factors, one in itself, while a composite number has more than two factors. As we studied in Lesson 19, the numbers 2, 3, 5, and 7 are prime numbers. That's right, Allie. The numbers 4, 6, and 8 and 9 are composite numbers. All composite numbers can be formed by multiplying prime numbers together. So 4 equals 2 times 2, which are two prime numbers multiplied together to create this composite number. 6 is the same as two prime numbers 2 times 3 equaling this composite number. 8 is a composite number multiplied or equal to having three prime numbers multiplied together, 2 times 2 times 2. 9 is the same. When we write a composite number as a product of its prime factors, we have written the prime factorization of the number. The prime factorizations of 4, 6, 8, and 9 are shown above. Notice that if we had written 8 as 2 times 4 instead of 2 times 2 times 2, we would have not completed the prime factorization of 8. Since the number 4 is not prime, we would complete prime factorization by breaking 4 into its prime factors of 2 and 2. In this lesson, we'll show two methods for factoring composite number, division by primes and factor trees. We will use both methods to factor the number 60. To factor a number using division by primes, we write the number in a division box and begin dividing by the smallest prime number that is a factor. The smallest prime number is 2. Since 60 is divisible by 2, we divide 60 by 2 to get 30. Since 30 is also divisible by 2, we divide 30 by 2. The quotient is 15. Notice how we stack the divisions. And although 15 is not divisible by 2, it is divisible by the next smallest prime number, which is 3. 15 divided by 3 produces the quotient 5. 5 is also a prime number. It's the only prime number that divides 5 is going to be 5. So you'd end up with 1 at the top in your quotient area. By dividing by prime numbers, we have found the prime factorization of 60. 60 equals 2 times 2 times 3 times 5. Use division by primes to find the prime factorization of 36. So I would start with 36 in the bottom, divide it by a prime number. 2 is the smallest prime number. 18 is the answer. 18 is divisible by 2 as well. It results in 9. 9 is divisible by a prime number 3, which results in 3, and 3 divided by 3 equals 1. Some people prefer to only divide until the quotient is a prime number, like they would have stopped right here. I like to go until 1 is at the top. Now I know I've got my list. This is the list of prime numbers. 2 times 2 times 3 times 3 equals the 36. So you've got 2 2's and 2 3's. To make a factor tree for 60, we simply think of any two whole numbers whose product is 60. Since 6 times 10 equals 60, we can use 6 and 10 as the first two branches of the tree. Notice how it's a tree shape. Starts with the number at the top, and you're branching off into two factors. The numbers 6 and 10 are not prime numbers, so we continue the process by factoring 6 into 2 times 3 and by factoring 10 into 2 times 5. The circled numbers at the ends of the branches at the bottom of the tree are prime numbers. We have completed the factor tree. We will arrange the factors in order from least to greatest and write the prime factorization of 60. 60 equals 2 times 2 times 3 times 5. Use a factor tree to find the prime factorization of 60 again. So you can see here 4 and 15 were used as the first two trees, and then we ended up with 4 is the same as 2 times 2, 15 is 3 times 5. You still end up with the same answers was previously stated here. All right, which one of these numbers are composite numbers? Go ahead and answer that. Composite numbers are not 19 and 23. The composite numbers here are 20 because you can divide 20 by 1, 2, 1, 2, 4, 5, 10, and 20. 21 is divisible by 1, 3, 7, and 21. And 22 is divisible by 1, 2, 11, and 22. So when you have a composite number, it's divisible by more than 1 in itself. Write the prime factorization of each composite number in problem A. So for part B, let me just place that right here. So for 20, let me just start with a factor tree. I'd have 4 times 5, and 4 can be split into 2 times 2, and 5 was a prime number already. So the prime factorization of 20 is 2 times 2 times 5. For 21, let's say split that up again, it'd be 3 times 7. Those are both prime numbers, so I'm done. So for 21, that's the same as 3 times 7, prime factorization. 22, if I was to split that up, I can see that the prime numbers 2 and 11 are the only things that it's divisible by. Both 2 and 11 are prime, so that means 22 is the same as 2 times 11. So those are the answers to the prime factorizations of those composite numbers. Letter C, use a factor tree to find the prime factorization of 36. So for letter C, you do have to start with 36 at the top. I'm going to break that down. I'd have 4 times 9. Both of those are composite. This would be 2 times 2. 9 would be 3 times 3. The answer to 36 prime factors would be 2 times 2 times 3 times 3. Letter D, use division by primes to find the prime factorization of 48. So for letter D, start with 48 divided by 2 would be 24. 24 divided by 2 would be 12. 12 divided by 2 would be 6. 6 divided by 2 would be 3. And 3 can be divisible by 3, which equals 1. My prime factorizations of 48 is 2 times 2 times 2 times 2 times 3. 1, 2, 3, 4 of them, and then that final one right there. Letter E, write 125 as a product of prime factors. So 125, let me just put that right here. Let me use a different color so it doesn't blend in too much. So for letter E, let me start with division by primes. So 125, that looks like it's divisible by 5. It'd be 25. 25 divided by 5 is 5. 5 divided by 5 is 1. Now I'm done. So the prime factors of 125 are 5 times 5 times 5. That's all there is to that one. Letter F, it says, write the prime factorization of 10, 100, 1,000, and 10,000. What patterns do you see in the prime factorizations of these numbers? All right, for letter F, let me just start right here. Prime factors of 10, let me just do this. Division by primes would be 5. This would be 5, which would be 1. So for 10, it is the same as 2 times 5. So that's the prime factorization of 10. Let's do 100 right here. Division by primes again is just easier for me. 100 divided by 2 would be 50. 50 divided by 2 would be 25. 25 divided by 5 would be 5. 5 divided by 5 is 1. So for 100, it would be the same as 2 times 2 times 5 times 5. All right, let me do 1,000 right here. 1,000 divided by 2 would be 500. 500 divided by 2 would be 250. 250 divided by 2 would be 125. 125 would be divisible by 5, which would get me to 25. This would be that. 5 divided by 5 is 1. Now what I've got is 1,000 is the same as 2 times 2 times 2 times 5 times 5 times 5. You might have recognized the pattern already for one looking at that. Let's do 10,000 right here. 10,000. And I'm going to divide that by 2 again. That would be 5,000. The smallest prime number that's divisible by is 2. That'd be 2,500. This is also divisible by 2. That'd be 1,250. This is also divisible by 2, which would be 625. 625 is not divisible by 2, but it is divisible by 5, which would get me to 125. 125 divided by 5 works. That would be 25. And this one is divisible by 5. And 5 is divisible by 5. So the prime factors of 10,000 are 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4. 1, 2, 3, 4. I've got to make sure I have 4 of them. And then I got to count 1, 2, 3, 4. Should be 4 of them there. Because the pattern, if I'm looking at the pattern correctly, if you didn't recognize the pattern, you can see there's 1, 2, 3, 4 zeros, 1, 2, 3, 4 twos, and 1, 2, 3, 4 fives. Here there were 1, 2, 3 zeros, 1, 2, 3 twos, 1, 2, 3 fives. Here there were 2 zeros, 1, 2 twos, and 2 fives. And here 1 0, 1 2, and 1 5. So the pattern is that. Excellent work. Today, make sure you guys do problems 1 through 30 in lesson 65 in the written practice. It's incredibly important that you always do problems 1 through 30 in Saxon math. It's a spiraling concept. It always gives you the practice from the previous lessons. And if you don't, you kind of miss some things. Excellent work.